All right, so we already kind of previewed this video in the 3.2 video. Basically, solving, we kind of want equal zero. If we don't have equal zero, it's not the biggest deal. We can work with, we can work without, either way. So solving quadratic equations. It's what we've been doing, but just with a little bit of different ending. We kind of want equal zero. So from here, we would kind of move the 49 over, but in reality, our goal, if we're missing this middle term, and it's not like a difference of squares, we're trying to get x squared equals. So I could just move that 31 over, and I get here 4x squared equals 80. Divide by 4, square root. 20 factors out, so I have a pair of 2's that come out. 5 stays inside, so we have plus or minus 2 square root of 5. The positive version and the negative version, when I plug in here, it ends up being positive. So that's why they both work. On this one, subtract 9, divide by 3, square root, but we got this imaginary number. We don't really put plus or minus in front of imaginary numbers. We technically can, but because they're imaginary, it doesn't really seem to matter. Anyway, that's a personal preference for your teacher, so just double check with that. Solve by factoring. So like I said, if we're going to factor, we need everything together. We need to say equals 0. So we move this over and equals 0, and then we factor like normal, and 5 and minus 9 gets me to negative 45, because otherwise, getting to positive 45, having these be the same signs, it wouldn't have worked anyway. So make sure you move that over. A value is 1. So throw the x's in front, factor it out. If these multiply to become 0, then one of these has to be 0. 0 times whatever, or whatever times 0. Either way. So if this first one is 0, if x plus 5 is 0, the next is negative 5. Plug in negative 5 there, get 0, negative 5 there, and get negative 14. 0 times negative 14, 0. If x minus 9 is 0, the next is 9. 9 minus 0 is 0. 9 plus 5 is 14. 0 times 14, still 0. On this one, same thing, we factor. Yeah, I'm trying to remember what order I went through. Kind of ignore some of this real quick. We factor and get negative 3, negative 8. And then we do our whole lovely fraction thing that gets me to x minus 3 and x minus 4. If that's equals 0, x is 3 over 2. If this equals 0, excuse me, x is 4. And I said, well, let me go back here. What do you notice about what's highlighted? This is negative 5, and that's positive 5. This is negative 9, or that's positive 9, this is negative 9. Really, they're just opposites of each other, right? Same thing here. If we took this 2 and divided both of these, which is kind of what we end up doing here at the end, negative 3 over 2 becomes positive 3 over 2, and negative 8 over 2, which is negative 4, becomes 4. And you could technically skip from here to the end, technically, but my students, I definitely want you showing all the in-between work. Oh, I'm sorry. Solve by factoring, and I gave them, and you can go ahead and pause the video and try these 4 out, because here in like 3 seconds, I'm going to switch to the next slide that has all the answers. This is what I did with my kids. I gave them some time to do this, and then the answers. This one only had 1 answer because it was the same answer twice. This one pulled out a greatest common factor, so it was x times x minus 8. Well, the x by itself could be 0. The x minus 8, x would be 8 if it's 0. So we just did some more practice. It's the same factoring we've been doing, but now we have this equals 0, where you set all the factors equal to 0 and finish solving from there. So yeah, that was solving quadratic equations.